This is going to be a little bit advanced or complicated for the very little kids, and if you're in the 12th grade, for example, you will understand most of it, and you will also be able to follow up on Google and YouTube if you have questions, but you can also send me the questions. I'm going to include these anyways because if you listen to it, even if you don't understand 100% of it now, you may get enough that later on you are going to remember and say, I remember something that was said by this guy with the funny beard, and maybe then go back and read again, listen again, and follow up. Okay, so as I said before, we will build the Earth system. It's like building a model. What is a model? Let's say you want to build a human body model, a robot. Let's say you're building a robot of a human body. You will start with the structure. You will add some instruments to get the signal to go to move the hand and open the fingers and grab the bottle here, and so that's a model of the human body you're building as a robot. When you want to build the model of the Earth system, you want to start with the simple things that we talked about, like the energy balance. That's what drives everything, right? So you want to start with looking at the simplest forms of energy coming in, thermal energy, energy going out, and deficit energy in high latitudes, surplus energy at low latitudes, and you want to start moving the atmosphere and so on. So let's start with that. Okay, so all these figures are provided by the nice people of the University of California, Berkeley. Where is it? California? It's in the western part of the US on the Pacific Ocean. On the west side is the Pacific Ocean, and Berkeley is a place where this university is. So we talked about, in the background you have a typical figure we show when we say Earth system. So you can get comfortable with that because I said that in words in the previous podcast. So we have the main energy source, the sun of course, and we have the components of the natural world. So you have water with its life, you have ice and glaciers and penguins, you have clouds with some snow and rain, and you have land, and in the ocean you have life with this nice dolphins and starfish and some other shellfishes here at the bottom, and you have people living with their cattle and their goat and sheep and doing their agriculture, and people have roads and they have cars and they have energy source, and there is a city maybe, and we have mountains with, if it's tall enough it has snow and glacier on top. We'll talk about glaciers later. And you have birds and vegetation and rivers and volcanoes and so on and so forth, right? There's also things on land here. Okay, so this is our natural sphere, and of course we are part of the Earth system, and now we have become a force that can change the energy balance, because by changing the land and the albedo we can change the energy budget. By removing forests and building things like lawns and pastures and agriculture, we can change albedo and carbon dioxide as well, right? So remember, if forest is sitting there and taking up carbon dioxide, building tree trunks and other carbon material, and if you cut it down, that carbon dioxide is going to come into the atmosphere. Okay, so with that you start with the energy, solar radiation coming into the Earth system, and some of it will be absorbed, some will be reflected, as we said already, based on the albedo. And Earth is a sphere and it's spinning around its axis, and it has got its tilt, which changes as over time, thousands of years, as we said, and it's got its orbit, which is in elliptical shape, and it has equinoxes and solstices, and we said those things also change on tens of thousands, hundreds, thousand time scales. So all those determine how much energy is coming in, and they also determine how much of the energy gets reflected, because when you change the energy, you change the amount of snow and glaciers and so on, and that changes the albedo. And remember, if albedo begins to increase, more and more energy goes back out because it's reflected. That means it gets colder and more snow falls if it's colder. On the other hand, if the snow and ice begin to melt, then albedo decreases, which means more energy is going to be kept in the system, less is reflected, so it gets warmer, which means more snow will melt. Okay, so and more it'll get further warmer. So you learned here again something we mentioned before. It's called the ice albedo feedback, which means if you perturb one thing, what does it do and come back and affect the initial. So you start by changing the snow cover, let's say, changes albedo, changes energy balance, changes temperature. That temperature again changes the ice cover or snow cover. So you have a loop. That's what we call a feedback. What's the best way to think about it? Every system is made up of components, as we said, and the components talk to each other and they feed back to each other, right? So this feedback is very important. How do you think about it? Let's say you are running an air conditioner or a refrigerator where you set the temperature. You can ask your siblings or your parents to show whether in your house there is an air conditioner, there is a refrigerator, and the thermostat is being used. So when you set the thermostat to, let's say, 25 degrees centigrade temperature, if the house gets warmer than 25 degrees, the air conditioner will turn on and will begin to blow cold air, and it will cool the temperatures and bring it back to 25 degrees centigrade. If it gets cold because the AC has been running and temperature drops below 25 degrees centigrade, then the thermostat will tell the air conditioner to go off, and the cold air is not blowing anymore, so the temperature begins to warm up, right? So that's a system which has a control. In the Earth system also, the albedo ice feedbacks with the energy coming in and going out act like a thermostat. Will they always control the temperature to be stable or remain constant? Of course not, because you have had ice ages, which we'll talk about later again. You may have seen a movie called Ice Age as well. Just 12,000 years ago, the last ice age ended, and Earth, with its orbital changes, has had ice ages and ages like now, the Holocene, where there is not much ice. Right? There is ice on Greenland, in Antarctica, on Himalayas, and so on. But when you have an ice age, there will be lots of glaciers everywhere, like North America, Europe, India will be colder than it is now. Oceans will be covered with sea ice, and so on and so forth. Okay, so this is how the Earth system works. And coming back to here, we already talked about how the energy balance begins to create atmospheric circulation, the winds, and that affects the air temperature. And these arrows indicate that there are feedbacks. If winds blow, that's going to change temperature. If temperatures change, that's going to affect clouds, and then you have re-radiation, so you have heat, thermal energy being created that's trying to escape to space, and you have greenhouse gases which are trapping that energy. So you have the greenhouse effect, which also affects the temperature, which then affects the evaporation and water vapor in the air and the clouds, and then the winds. So these feedbacks, these arrows are running back and forth, and in this direction, and so on. These are feedbacks, right? What is the feedback in my system? Let's say I'm speaking for a few minutes, I feel thirsty, my brain tells me you are thirsty, you should drink water, so I will reach for the water bottle, I will open it and I will drink some water, and my brain will also tell me, look at what you are lifting. It's a big bottle, so use energy to lift it. If it is a paper cup, use less energy so you don't crush it. So all these are signals and feedbacks, right? So that's how the system works. So let's leave this podcast here in terms of the Earth system, just about the energy balance needed and how that energy balance is done by moving heat around with winds, and how the winds then begin to create evaporation clouds, and greenhouse gases are of course there, and we'll come back and see how humans are changing these balances to create global warming. Okay, so I hope it's clear. I'm using only one figure as far as possible in a podcast to explain the concepts. If you don't understand, obviously this is complicated if you're very young, but you can listen again, or you can look at the figures carefully, or can ask questions to the teachers, to your parents, to your siblings, or back to me. Okay, so I'll see you in the next podcast, and add some complications to the Earth system to see what other things happen when we add more components of the Earth system to our model. Remember, we are building a model, a conceptual model, like a robot. We are building a model of the Earth system. Okay, see you in the next podcast, kids.